Okay, we're going to look at log rules today. There's a couple of things I want to show you before we start looking at our log rules. And imagine you wanted to know what log 2 of the 8 is. Log to the base 2 of 8. So, okay, I don't really know what it is. Let's put a little question mark in. There's my base, there's my answer, there's my power. So 2 to the question mark is 8. So the question mark must be 3. Well, your calculator will do that for you. If you look there on that little button, you can type log to the base 2 of 8 in, and it will give you 3 as your answer. That's the first thing. The second thing I want to say or show you is that log to the base 10 of 1,000 is obviously 3, isn't it? Yep, must be. But if we wanted to work out that it was 3, we could just use that red button and type into here log to the base 10 of 1,000. Now, mathematicians, if they are ever in base 10, and this is only for base 10, no other base works, but only for base 10, they often don't bother writing the base in, only if it's base 10. So you could also just type into your calculator log to the 1,000, and that button is here. All right, so if you just type in log to the 1,000, your calculator will give you 3 as an answer. Okay, should we do a few log rules? Let's do a few log rules. Let's get rid of him. Okay, the first log rule is called the addition rule. And what I want you to do is I want you to, this is the one students always get wrong. I want you to just take your calculator, grab your calculator, and see if log 5 plus log 7 comes to log 12. Does it come to log 12 if you do that? If I do log 5 plus log 7, let's see what I get. Log 5, I always press enter then at that point, plus log 7. I get 1.54 for that. And what do I get if I type in log 12? So log 12 on my calculator gives me 1.07. So they're not right, are they? They're not equal. And lots of students make this absolute classic error of thinking that logs follow the same thing as algebra. They don't, all right? So what we've just written there is complete and utter rubbish. So we're going to get rid of it. So what actually does happen to log of A plus log B? I'm going to show you. Let's get all rid of all this. Yuck, 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 yuck. Okay, so what it actually is this. Here it is. Here's my little log rule. Let's make him a bit bigger. The log of A plus the log of B is the log of A times B. So if I wanted to do the log of 5 plus the log of 7, it's not the log of 12, it's the log of 5 times 7. So it's actually the log of 35. If you check that on your calculator now, you'll see it works. Okay, now you're probably wondering why that works. Probably the easiest way for me to explain it is this. The logs are obviously the inverse of the indices. I don't know why I've written that. Let's get rid of that. So if you had, for instance, 2 squared times 2 cubed, what you would do is you would add the powers together. So you'd get 2 of 2 plus 3. So when we're timesing, we're adding. So when we're adding, we're timesing. That's probably the easiest way of explaining it. Okay, next up we're going to have a little look at the subtraction rule. And again, if we think about where it comes from, it looks like this. There he is, the subtraction rule. So if we are subtracting one log from another log, it's the same as the log of A over B. Now, do you notice that when we're doing this, that we are reducing these logs to a single log? So we're saying the log of one plus the log of the other goes to a single log. The log of one minus the log of the other goes to a single log. And for instance, let's just run one through. If we had the log of 20 minus the log of 2, that would be the same as a single log. Notice we don't write the word log twice, it's just a single log of 20 over 2, which is the same as log 10. And of course the reason that that one works is if you're if you're dividing indices. So let's just say you had 2 to the 10 divided by 2 to the 3. You would get your answer by doing 2 to the 10 minus 3. So that doesn't look much like a 3, does it? So subtracting is the rule when we're dividing. So subtracting when we're dividing. Okay, so the third power rule, sorry, not the third power rule, the third log rule is called the power rule, and this is probably my favourite one because it's really simple. But if you have a log with a power, notice he's got a power, so let's just say you wanted to work out what the log of 2 cubed is, the power can basically move anywhere. All right, so he can move down to the front. So he's the same as log 3 to the 2. All right, so the power shifts down and he can just kind of interchange. The rarest of the log rules, here he is called the change of base rule. Now, you won't need him very often, very, very rarely, and you'll need him if, for instance, you've got a log in a certain base. Let's say you've got a log base 9, and you want to get it into log base 3. That's a bit strange, isn't it? So you want to change the base of your log. Okay, so what we're going to do is, the easiest way to do it is to write out log of base 9. And then what you're going to do is you're going to take your formula from your formula book. All right, there he is. You're going to take your formula, and then you're going to write log with a line and log with a line. Okay, so you're just going to set yourself up like that first. Now notice that we want to change it to base 3. That's the base we're wanting it to become. So we just literally pop the bases in down here. And then we can either refer to the formula book or we can refer to, I call it Martha's Grandad's trick, which I think is absolutely fantastic. So Martha's Grandad's trick says the 9 here is on the bottom. So because he's on the bottom, he goes on the bottom. And the x here is on the top, so because he's on the top, he goes on the top. Okay, so then what are we left with? We're left with log 3 of x over, and then we've got to work out what log 3 of 9 is. Now you can either shove that into your calculator, or if you happened, well, you would have a calculator for C2, but if you didn't know, you could go question mark, that's your base, that's your answer, that's your power, 3 to the question mark equals 9, so it must be 2. So it's actually a half log 3 to the x. Done.